we knew the world would not be the same. A few people laughed, a few people cried, most people were silent. I remember the line from the Hindu scripture, the Bhagavad Gita. Vishnu is trying to persuade the prince that he should do his duty, and to impress him takes on his multi-armed form and says, "Now, I am become death, the destroyer of worlds." I suppose we all thought that one way or another. This is how Robert Oppenheimer, who led the team that invented the atomic bomb, remembers the events of July 16, 1945, when the first atomic bomb test was carried out. According to some, the atomic bomb caused the deaths of hundreds of thousands of people by inventing it, and according to others, it caused inhuman destruction in Japan, which was already on the verge of leaving the war. The threat of the atomic bomb has not yet been eliminated. In fact, it can even be argued that the danger is greater than ever, because as we move away from World War II in time, we begin to forget the emotional burden of the destruction experienced, how painful it is. Now let's think together. What is needed to make an atomic bomb? The most basic feature that basically separates an atomic bomb from an ordinary missile or bomb is, of course, the fuel. This fuel is the uranium and plutonium elements used in nuclear bombs and nuclear energy facilities. So why do we use uranium and plutonium? Actually, the answer is very simple. Uranium is the most abundant element among the largest atoms on Earth. Thanks to this, we can break larger atoms more times. As I explained here, the breaking down of atoms is called fission in science. Thanks to the energy released by fission, we obtain great power. If you were to open a uranium mine, 99.27% of the uranium you would extract is the basic uranium-238 atoms that we all know in the periodic table. Contrary to what people think, this uranium is quite stable and easier to find than other uraniums and has a half-life of 4.5 million years. Contrary to what is believed, there is not only one type of uranium in nature, just as it can be found in every atom. There are isotopes in uranium, where the number of protons is the same, but the number of neutrons and therefore the stability of the atomic nucleus is different. For example, in the uranium mine you opened, the remaining 0.7% is uranium-235, and 0.005% is uranium-234. In addition, the lifespan of these isotopes is not short for us, but it is short for the universe. For example, the half-life of uranium-235 is 700 million years, and the half-life of uranium-234 is 245,000 years. Of course, this period is quite short for our 4.5 billion-year-old world, and this makes uranium valuable according to its class. When I was talking about uranium a moment ago, I mentioned their half-life because uraniums spend the rest of their half-life deteriorating and useless. We cannot use the basic uranium-238 that I mentioned at the beginning directly in bombs. But do not worry, these uraniums are not completely worthless. You can also turn them into plutonium-239 by a simple neutron bombardment process. And this is as good a fuel as uranium-235. So, the uranium enrichment thing that you hear about in the news all the time is isolating and multiplying the more unstable but rarer isotopes that you can extract from the mine. And if you're going to make a nuclear bomb or a reactor, you need at least 15 kilos of uranium or 4 kilos of plutonium. And of course, governments use a lot more than that. Let me tell you how to enrich uranium. You can't separate the isotopes of an atom because they have the same properties, but you can perform a physical separation process by using the slightly different masses of each isotope. For example, you can do gas diffusion. That is, you can separate a cauldron into two with a very spongy barrier. You can put the uranium isotopes that have not yet separated into each other in gas form on one side of the barrier and apply vacuum to the other side. Due to the pressure created by the vacuum, light isotopes pass through the barrier faster than heavy isotopes, and you can purify your uranium by repeating this process over and over again, or you can separate them with a centrifuge. Don't be afraid when you hear the word centrifuge. It is a much easier process than you think. We use the centrifuge tool seen in the image to make a centrifuge. It is a laboratory tool that usually performs a fixed-axis circular rotation movement with the help of an electric motor. Its logic is very simple. Thanks to the high speed, it separates the mixtures put in it according to the sedimentation principle. But don't forget that as you purify your uranium, it will become increasingly difficult to enrich it. More and more advanced equipment and techniques will need to be used. For example, it is easy to increase uranium from 5% purity to 10%, but it is very difficult to increase uranium from 90% purity to 95%. And the purer your uranium is, the more efficient your system will be, which is what being advanced in atomic technology means. Let's say we did all of this, and now we need to split the uranium atom. That's why we need to send neutrons to those atoms, so we can use the tremendous energy that comes out of the splitting of the atom. This is exactly what we call nuclear fission. The number of protons that are formed by the splitting of our fuel is different. For example, during the fission of uranium, depending on parameters such as the energy of the atom, the energy of the neutron, and the angle of impact, a wide variety of atomic pairs can be formed. In general, atoms such as iodine, cesium, krypton, strontium, and barium and their isotopes are formed. But what is important for us is that no matter what the atoms are, this energy is released with the splitting of the atom, and more importantly, more neutrons are released as this atom splits, and thus a chain reaction occurs, and this makes the bomb uncontrollable. This neutron scattering is what distinguishes an atomic bomb from a nuclear reactor. If you can keep the number of scattered neutrons below a certain limit, for example with control rods made of boron element, you can also control the speed of atom disintegration. Thus, you can use the energy scattered from each atom disintegration in a controlled manner and convert it into useful energy. This is what we call a nuclear reactor. If you cannot keep this chain reaction under control, it is called a nuclear disaster or nuclear leak. What people do to destroy each other is truly extraordinary and mind-boggling. If we could use science to ensure peace and prosperity instead of destruction, there would be no need to colonize Mars. Anyway, you can click the I button above to learn the differences between an atomic bomb and a hydrogen bomb. I wish you a good day and see you in the next video.